We're just going to look at a few applications of arithmetic and geometric series. The first one's just a couple of questions that have appeared over the years. So this one from 2007 two-unit paper. Heather's going to improve her fitness level, which is very good of her. But on the first day, she swims 750 metres. Then each day after that, she's going to swim 100 more metres than the previous day. That is, just in case you can't work this out, they explain everything for you in the HSC. She swims 850 metres on the second day, then 950 on the third day, and so on. Write down a formula for the distance she swims on the nth day. So, all right, we're going to pull out all the information. So we read this question, we go, oh, look, the first day, so A would be 750. Every day after that, 100 more. So adding a common difference each day, D is 100. We want to find the general term, term n. Well, we know term n is a plus n minus 1d, and we just simply sub into our formula, a little bit of calculation, and there it is. We have a formula for the general term, 650 plus 100n. How far will she swim on the 10th day? So now we just sub into our formula that we just worked out. We're going to find term 10. So term n, 650 plus 100, sub in 10, 1,650 metres, which is a pretty decent effort. Okay, what is the total distance she swims in the first 10 days? So now we want to find the sum, the 10. So I'm going to use the n on 2, 2a plus n minus 1d. I suppose I could have used a plus l because we know she swam 1,650 on the last day. So subbing into that one, and we just get 12,000 metres. Or, as I say, I could have used the a plus l formula, and of course it comes up with the same answer. Here's the interesting question, because of course we'd want to know this. After how many days does the total distance she has swum equal the width of the English Channel? Which is, by the way, 34 kilometres. So, we want to know when the sum to n is 34 kilometres. So n on 2, 2a plus n minus 1d, but we want it in metres, so 34,000 metres. And we end up with a little quadratic to solve here, eventually. Oh, there it is. What multiplies together to give minus 68,000? Oh, no. We've got 100n squared. Oh, divide everything by 100. Phew, that's better. Multiplies together to give minus 680. Adds together to give 14. 34 and 20. So we have two possibilities. But of course, to solve our problem, it must be the positive one we're looking for, because we're not going to have on the negative 34th day. So 20 days it took to swim the 34 kilometres. Right. Here's another one. Company sales are declining by 6% every year. 50,000 items sold in the year 2001, during which year are sales going to first fall below 20,000? So A is 50,000. R is not 6%. Right? It's declining by 6%. So the actual ratio is 0.94. So we've got 94% of sales each time. And we want to know when is term n less than 20,000. So let's sub it in. When is 20,000 greater than 50,000, 0.94 to the power of n minus 1. And we can use our log, of course, to solve this. But remembering, because eventually, there we go, I'm going to have to divide by log of 0.94, but log of 0.94 would be a negative number. So we've got to change the inequality sign, because of course if you change the sign, you change the sign. Log 0.4 divided by log 94, 14.8, add 1. So n is greater than 15.8. But we've got to answer the question. The question said, during which year? it will be the 16th year that it happened. 2005 paper. Oh yes, Anne and Kay. This is a great question. Anne and Kay, employed by an accounting firm. Anne's condition of employment, initial salary 50,000, and she decides she'll take an increase of salary of 2,500 every year. Whereas Kay's condition, she said, yeah, I'll take 50,000, but rather than give me 2,500 each year, I want you to increase my salary by 4% every year. So, arithmetic is Anne. Oh, A, Anne, A. D is 2.5, whereas K is geometric. Oh, K, oh, it doesn't work, does it? Oh, well. It's also 50,000, but our ratio this time is 1.04 because we're increasing by 4% each time. So the first question is, for 2 marks, what is Anne's salary in her 13th year? So we'll have to come up with our formula for term 13. Term N is A plus N minus 1D. So subbing in A and N minus 1 will be 12D. Her salary is $80,000. How about K? Who's going to get more money? Who took the better conditions? So it's still term 13, but this one's geometric. Subbing in 50,000, 1.04 to power 12. Ah, she wins by $51. Took 13 years to get ahead, but she did it. Kay earns $80,000 and $51. Oh, and 61 cents. Don't forget the 61 cents. Now, here's the interesting question. The total amount they've earned over 20 years. So we've just seen that, okay, in the 13th year, Kay's going to start earning more. But how much more after 20 years? How much more money will she have got after 20 years? So we're going to find the sum to 20. So for Anne, it's arithmetic. And subbing into that, in 20 years, she's done $1,475,000. Whereas K, subbing in our geometric one, $1,488,903. So they want to know how much extra. So we do a subtraction. She's got herself an extra almost $14,000 there over 20 years. All right. Limiting sums. They love asking these ones. So 2007, 1D, just a quick question at the start of the paper. Limiting sum, 3/4, 3/16, 3/64. So A is 3/4. The ratio for this one is 1/4. Remember, sum to infinity is A on 1 minus R. So we get 4 on 1 minus 1/4, which is just 1. 2003, question 7, much later in the paper. Much more interesting question. Find the limiting sum of this geometric series, because it combines surds. But it is still a geometric series. A turns out to be 2. Our ratio is 1 on root 2 plus 1. So sum to infinity, A on 1 minus R. 2 on 1 minus root 2. Playing around with that fraction. Rationalise the denominator. We end up with 2 plus root 2 for our sum to infinity. They like these sort of questions. Explain why it does not have a limiting sum. This is part 2 of the question. And of course, all they're looking for is that you know that the ratio needs to be between minus 1 and 1. In this case, the ratio is 1 on root 2 minus 1. And that turns out to be 2.414, which of course is bigger than 1. No good. Then, this was a 2-unit paper, but question 9A, maybe one of the harder series sequences questions they've had in the 2-unit paper. Here's this series. It goes 1 minus tan squared plus tan to the power of 4, and so on. So A is 1, fair enough. Our ratio is minus tan squared theta. So the question says, when the limiting sum exists, find its value. So sometimes it will exist, sometimes it won't. It all depends on the value of theta, of course. Some values of theta will make that in between minus 1 and 1. Some values of theta will make it greater than. So we're saying, okay, well, when theta is okay, what will the sum to infinity be? So a on 1 minus r, we get a, which is 1, on 1 minus tan squared, 1 plus tan squared. They want it in the simplest form, of course. 1 plus tan squared is? Oh, there you go. That's it. 1 over sec squared, which becomes cos squared. Now, they're saying we're going to restrict theta to between minus pi on 2 and pi on 2. Right? But for what values will the limiting sum exist? Okay. We know limiting sums will occur when it's between minus 1 and 1. So we're saying tan squared theta, or minus tan squared theta, is between minus 1 and 1, which is the same as saying tan squared theta is between minus 1 and 1. So I divide everything by negative 1. I get the same inequality in this case. But that just looks ugly. Swap it back around. Oh, that's better. Okay. I mean, it's still saying the same thing. It just looks horrible. Now, if tan squared is in between minus 1 and 1, obviously it can't be negative. But tan can. So actually tan theta will also be between minus 1 and 1. Right? You want to square tan and get a number that's between minus 1 and 1. Or numbers between minus 1 and 1 when you square them. Yes, you won't ever get the negative ones, but you will get values in between. So we're basically saying, when is the tan curve between minus 1 and 1? Okay, well, we know when it's equal to 1. That's a plus or minus pi on 4. So there's my graph. I know it's equal to 1 at minus pi, negative 1 at minus pi on 4, positive 1 at pi on 4. So basically, we're talking about values in between those. We'll end up with answers in between minus 1 and 1. So I think looking at the graph makes solving that particular inequality a lot easier. Minus pi on 4, less than theta, less than pi on 4. A very hard question for a 2-unit paper. All right, let's have a go at some of these applications. Just a handful of questions to look at there.